Okay, number 6 and 4.4 is asking you to find the intervals of concavity here on this function. Y is equal to 5x squared plus x to the fourth. So concavity comes from our second derivative, so we're going to need our first derivative, dy dx. Looks like it's going to be at 10x plus a 4x cubed. And then we'll go to our second derivative, d2y over dx2, and that's going to be at 10 plus a 12x squared. Okay, we're going to set that thing equal to 0, and we're going to solve for it here. And let's see, we're going to get a 12x squared is equal to a negative 10. I think I see the problem here. X squared is going to equal negative 10 over 12, which is a negative 5/6. And then we would go to take the square root of both sides. But of course, when we end up taking the square root of a negative, we don't get a real solution. Now, what that tells us here is, guys, there really is no point of inflection right here. We kind of end up with an empty set right here. There is no value of x at which the second derivative is going to equal 0. What that means, and I bet whoever asked this question got to that point and then wasn't quite sure what to do with it, what that means is that our second derivative never changes sign. That means that it's either going to be always positive or always negative. Well, as you look at this one real quick, x squared is always going to be positive or 0, times 12, same thing, and adding to 10 to that, we're going to find that our second derivative, d2y over dx2, is greater than 0 for all x in the domain of this function right here. And that tells us, let's go ahead and answer the question right now, that y is going to be concave. If our second derivative is positive, that means we are concave up for all real numbers here. So that'll be the interval from negative infinity to positive infinity. And if we think about what we know about a positive fourth degree function, guys, my guess is that this graph right here, let me think about it real quick, it's going to be 0 when x is 0. I don't think this graph is ever going to be negative right there, so I've got a feeling this graph maybe looks something like that. And if I'm right about that, that would kind of support this idea that we came up with right here, that this graph is always going to be concave up and is never going to be concave down. So that can happen sometimes, maybe not the prototypical example, but one that we should know how to handle. Your second derivative might not ever change sign, and it might be either concave up or down for all real numbers.